Okay, so this is chapter 2, flow of water through soil. So the learning outcome of this chapter 2 is to discuss the concept of head and hydraulic gradient according to the Darcy's law, and discuss about laboratory determinations of permeability of soil, and also perform analysis of laboratory tests to determine the permeability characteristic of the soil. Okay, this is the summary for the whole chapter. So basically, when we are talking about the flow of water through soil, is actually referred to the terms of permeability. So what is the permeability actually? So by definition, is actually the capacity of soil to allow water to flow through it. Or we can say that it's actually to measure how is water flow within the soil mass, whether it's easier or it's not really easy. Okay, so it depends. How about the measurement? Sure, the measurement later on we will base on the K value. So we call it as a coefficients of permeability, or also known as hydraulic conductivity. So some books use hydraulic conductivity, but that one also known as coefficients of permeability, the K value. So that K value will represent the permeability of soil. It can be higher K value, it can be lower K value. So according to Bernoulli equation, okay, when we are dealing with the flowing of water, normally it's based on the Bernoulli equations in the any kinds of mediums. Okay, so in the water flow, so the term of pressure normally used as a total head. They are using terms of head instead of pressure. In the water, we call it as a head or H. Okay, they punya symbols. Alright, so according to Bernoulli, the flow of water is due to the elevation. So we have this Hz, and then also due to the pore water pressure, gamma water, unit weight of water, and also due to the velocity, V square over 2G. Okay, but then when we talk only through soil, the flow of water through soil, there are only these two terms that we need to consider. Okay, usually we ignore the factor of velocity to the gravity, because due to the resistance offered by the granular structure, knowing that the soil have the solid particles, so that the solid particle becomes obstacles or resistant to the velocity of the water. So when with water soil, so it's only have Hz, the elevations, and also the pore water pressure and unit weight of water. And it also related with the gradient. Okay, a gradient, we know that if we have more stiff gradient compare with the less stiff, so the flow of water is more easier at the stiff area compared to the flat terrain. Alright, so the velocity is actually from the I equivalent to H over L. So you can see here at this schematic diagram, when there are two piezometer installed within the soil mass, soil sample, so the movement of water due to the different head loss, H here, and also based on the length path of the water. Alright, so this is L, and then you will have the gradient here. Alright, so I is the hydraulic gradient that will also affect the permeability of the soil. Alright, and then based on the Darcy's law, okay, we're also referring to the Darcy's law, where the velocity is equivalent to coefficient times with the hydraulic gradient. Okay, so from the Darcy's law, the higher the steep the gradient, the velocity will be higher. So they have V equivalent to Ki. Alright, so this is the discharge velocity here. And then the quantity of water, the flowing out of quantity of the water, which is Q, is equivalent to Q over TA, the q to the time here. And they also q, the inner part, that q equivalent to v. V is the velocity, a is the area of the sample. Okay, area of the sample.